Okay, so we're on to the back side of the Chapter 7 Rationals Review. The first 3 problems, this number 9's over there, I'm going to try, ask us to simplify each expression and state the values that are undefined for each expression. So we're going to start out with number 7. Our first step in simplifying, multiplying, and dividing is always to factor. So when I look at this, I see 8x cubed plus 27, and by now we should recognize this is a sum of cubes, where our a is 2x and our b is 3. So the numerator is going to factor to 2x plus 3. So it's a plus b, and then it's a squared, so that's 2x squared, 4x squared, 2x in parentheses squared, so I got to square the 2 and the x, minus 2a times b, so that's 2x times 3. Keep pulling that down. 6x and then b squared plus 9. 3 squared is 9. So that's our numerator. The denominator is a trinomial with a coefficient. My leading coefficient 2x means it's got to be 2x and x. And 3, positive 3 and a positive 5. So 3 and 1. If I have this, that gives me 2x, and that's 3x. They're both positive because these are both positive. So 2x plus 3 and x plus 1. So now that I have it factored, I can look and see what values would make the denominator 0. So I take 2x plus 3. I'm going to do this before I simplify. Set it equal to 0, and I get x cannot equal, well, the 2x plus 3 cannot equal 0. So x cannot equal minus 3 divided by 2, negative 3 halves. And then x plus 1 cannot equal 0. So x cannot equal negative 1. Now, the book doesn't list both of these. It only lists the one that gets canceled out because it says it's obvious that the x plus 1 is not going, or it can't be negative 1 because of that. So to keep the expressions equivalent, the book will just say that negative 3 halves cannot equal 0. We divide out our common factor of 2x plus 3, and then so my final answer, which I'm going to run out of room here for, is 4x squared minus 6x plus 9 over x plus 1. And the way we wrote our undefined values is x cannot equal negative 3 halves and negative 1. So I want you to write down all of the values, not just the ones that get canceled out like the book did. Number 8, we're going to factor the top. I'm going to factor out a negative 1, and then I'm going to make that 9 plus x, and then the bottom is x plus 9, x minus 9. So right here, now that it's factored, what values would make these expressions equal to 0? X cannot equal 9 for this expression here, or negative 9 for this expression. Now 9 plus x and x plus 9 are the same, so when they divide they get 0, because addition I can rewrite in different orders, and my final answer on number 8 is negative 1 over x minus 9, and x cannot equal 9 and negative 9. The last one in that group is number 9, 4x squared plus 4x over 12x squared minus 12. So I'm going to factor out a 4x on the top, and I get 4x times x plus 1. And on the bottom I'm going to factor out a 12. And I get x squared minus 1, and x squared minus 1 is 12 times x plus 1, x minus 1. So at this point, again, we'd look at what would make this denominator equal to 0. X would not equal negative 1 or positive 1. And then we can divide out our common factor of x plus 1, and 4 goes into 12 3 times. So I end up with x in the numerator and 3 times x minus 1 in the denominator. There's my final answer there. Okay, so the rest of them say perform the indicated operation, and it's so important on the test that you pay attention to which one you're doing. These are multiplication. 10, 11, and I believe 12, if we could see it, was multiplication. 13, 14, 15 are division. Their rules are different than the adding and subtracting. You do not need a common denominator to multiply and divide. You need a common denominator to add and subtract. So we're going to follow the same steps. Step 1, factor everything, and then we will divide out our common factors. So x cubed minus 64 is a difference of cubes again. X minus 4, a minus b, a squared, plus ab, that's 4x, plus b squared is 16. Let's factor out a 2 times x squared minus 16. And this one is factor out a 2x. And we get x plus 3. And then we're going to factor this 2x and x. I'm going to put the 3 here and the 1 there because that gives me 6x and 1x, which will give me a 7 if they're both positive. And x squared minus 16 we can write as x plus 4, x minus 4. So if we're going to look at what numbers will make the domain restricted, we're going to say that x cannot equal negative 4, positive 4. When I solve that equal to 0, I get negative 1/2. And when I solve that one, I get a negative 3. So it's only the denominators in division. And let's see what factors are going to divide out. This x minus 4 divides out. This x plus 3 divides out. And the 2 divides out here. And what I'm left with is, I'm going to encroach on this problem over here, x squared. This x is left as well, so x times x squared plus 4x plus 16. Remember, in the difference of cubes, this does not factor. There are not two numbers that multiply to 16 and add to 4. And that what's left on the bottom is x plus 4 times 2x plus 1. And you don't need to multiply those back out. You can leave them already. You can leave them in factored form. Let's see. Okay, number 11 is again multiplication. So the first thing I need to look at is, can I factor anything? And really there's no addition or subtraction, so I can't factor it like we did number 10. We're going to, sometimes I like to just multiply together the top and the bottom, and then I line up my variables. So 3 times 6 is 18, and I get x cubed because x squared. X times x squared is x cubed, y to the 4th, and z to the 7th. And then 4 times 3 is 12, x, y squared, z cubed. And now I can just simplify. Okay, 18 and 12 have common factors of 6. I didn't mean to do that. So that's 2 and that's 3 when I divide them both by 6. The x cubed divided by x squared, so I'm going to 3 on top, 2 on the bottom. X cubed divided by x is x squared, positive x squared, or x to the positive 2. Y to the 4th divided by y squared is y squared, and z to the 7th divided by z cubed is z to the 4th. So my final answer is 3x squared y squared z to the 4th over 2. And x cannot equal 0, y cannot equal 0, and z cannot equal 0. Okay, so we are on to number 12, our last multiplication problem. Again, first step, factor. We can factor, these are all have binomials, trinomials, and those need to be factored before we can do any canceling. So let's see, 3x squared minus 5x minus 2, well, 3x. So 3x times x will be the only way to get 3x squared, and 2 and 1 is the only one to get 2. So let's check my outside 6x and my inside 1x. Can that give me negative 5x? Yes, if the 6 is negative. So the negative 2 and a positive 1. And then what two numbers multiply to negative 10 and add to 3? That's x plus 5 and x minus 2. And then what two numbers multiply to negative 15 and add to 2? X plus 5 and x minus 3. And then I can factor 9 out of that, and we get 3x plus 1. So this is the point where we would decide what numbers x cannot equal. X cannot equal negative 5 from the x plus 5, positive 2 from the x minus 2, and if I solve 3x plus 1 equal to 0, I get negative 1/3. And that's our list of our domain restrictions. Now, can I cancel any common factors? I have an x minus 2. I have an x plus 5 divided by x plus 5. That equals 1. A 3x plus 1 and a 3x plus 1. And what's left? Just x minus 3 over 9 is my final answer. Okay, let's look at number 13. How does division differ from multiplication? We multiply by the reciprocal. That's how we divide fractions. So we're going to flip this fraction. This is going to become times 2x plus 10 over 6x minus 3. When we look at domain restrictions on division, we have to look at both the numerator and the denominator of the second fraction because you're dividing by that fraction. So if any of it's 0, you're dividing by 0. So that's something we have to think about when we write that down. So let's look at the top, the numerator of the first fraction. We're going to factor out a 6. And we get 2x squared plus x minus 1. And that's going to become 6 times 2x and x. The only way to get 1 is 1 and 1, so the question is, where do my negatives go? I need it to be the bigger number to be positive because the middle term is positive. Since this is positive, my bigger number needs to be positive, so that's the 2 times the 1. So we're going to put the plus here and the minus there. Then I'm going to write that out, x plus 1, x plus 1. And 2x plus 10 is 2 times x plus 5. And I can factor out a 3, and I get 2x minus 1. So my domain restrictions are that x cannot equal negative 1. From this one, it would give me a domain restriction of positive 1/2 if I solve it equal to 0. And then the numerator on the number I divided by. So we also have to look at x plus 5. So it can also not equal negative 5. What divides out? My 2x minus 1, my x plus 1. If I look at my numbers, I get 6 times 2 is 12, over 4 times 3 is 12, so those are going to divide out. And the only thing left is x plus 5 over x plus 1, and that's my final answer. Let's look at number 14. We're going to change it to multiply again. We're going to write 3x cubed plus 3 over 4x plus 12. And x squared plus 6x plus 9 is x plus 3 times x plus 3. Our factoring skills are super important here. X squared plus 7x plus 6 is x plus 6 and x plus 1. Times, this is 3 times x cubed plus 1, which is going to be x plus 1, x squared, minus x plus 1. And that doesn't factor anymore. And then the denominator is 4 times x plus 3. So we're going to ignore this part because we factored it more. And here's my numerator, and here's my numerator. So what can I cancel? This x plus 3 with this x plus 3, that divides out. The x plus 1 and the x plus 1. And that's it. Nothing else is going to cancel. So I have in the top, in the numerator, x plus 3 times x squared minus x plus 1 over 4 times x plus 6. And if I go back and look at my domain restrictions, x cannot equal negative 6. X cannot equal negative 1. X cannot equal negative 3. And then the numerator, negative 1 as well. The x squared minus x plus 1 produces complex fractions, so we don't have to worry about writing those down. We don't need to write down complex domain restrictions. Okay, let's look at 15, and then we'll do a separate video on the rest of it. So let's see, can I bring 15 over here? Okay, number 15 is our last word, our division problem. So we're going to change it to multiply. I'm going to cross that out. I'm going to write 6a plus 6b over 3a minus 6. And b cubed minus a cubed is a difference of cubes, where it's b minus a. It's kind of tricky. It's reversing the variables. And then b squared plus ab or ba plus a squared. And a squared minus b squared is a plus b, a minus b. And then I can factor out a 6, and I get a 6 times a plus b, and 3 times a minus 2. And so my domain restrictions here get a little tricky. We have to take a plus b cannot equal 0, so a cannot equal negative b. That's not going to be on the test. A cannot equal b, because if I take a minus b equal to 0, can't equal 0, so a cannot equal b, and a cannot equal 2. So those are our domain restrictions. What cancels out? What divides out here? We have a plus b, 6 and 3, that becomes a 2. And then b minus a and a minus b, they are opposites, so they divide to equal negative 1. So what we're left in the numerator with is a 2 times a negative 1, so negative 2, b squared minus ab plus a squared, a squared divided by a minus 2 on the bottom. And that's it. That's my final answer. There's no simplifying because this is negative 2 times this trinomial, and a minus 2, remember, is its own factor and it can't be separated.